Thousands of years ago, children our age were learning valuable skills, stuff like war tactics and debauchery. And then the Greeks showed up, dooming millions of students to eternal confusion and boredom. Among these is a guy named Hipparchus, who invented trigonometry, which is what you decided to learn by watching this video. So you specifically either clicked or were forced to click on this video to learn about this, SohCahToa, or the trigonometric ratio. Those are important terms to remember, so keep them in mind. But first, we gotta backtrack. So what shape is this? If you're normal, you'll say it's a triangle. If you're unfunny, you'll say it looks like my mother. The reason why we need to talk about triangles is because of right triangles in specific. A right triangle looks like this. What distinguishes it from the other types is that it has a right angle, or 90-degree angle. Because of that, these little guys need some elaboration. So here's what you need to know. This right here, this is a hypotenuse. It's the longest side of a right triangle, and you can tell it's the hypotenuse via a couple ways. Though for convenience, just note that it's the side opposite to the right angle. The other two sides don't really have a special function like this one, but they're there. However, we do need to go over the opposite and the adjacent. Let's say the angle given to us in a problem is here. No, it's not the right angle. If another is given and you're asked to find the opposite or adjacent, they want you to refer to the other angle. This is because the opposite of the right angle is always the hypotenuse, which can't work because the hypotenuse is its own thing. Now, let's define opposite and adjacent. So when asked for either of these, we are talking about sides, not angles. To find the adjacent, all you need to do is look at the connecting side that isn't the hypotenuse. The opposite side is the one opposing the angle, like the hypotenuse for the right angle. So now that we have that out of the way, what is SohCahToa? Why do we need to know what these are? Well, to be honest, the coolest thing you can do with trigonometry is calculate where something you propel will land, like a mortar, or the distance between you and that cute girl in the adjacent apartment who you definitely don't stare at. Let's begin with so, or sine, or as I call it, sin. Why do I call it sin instead of sine? Because ancient Greece. So is sine, opposite, and hypotenuse, which is a convoluted way of explaining a formula, being that sine equals opposite over hypotenuse. So let's get into an example to explain this. So here we have a meter demonstrating a classic political phenomenon. On the high end of this we have Gaius Julius Caesar, and at the bottom of the barrel is William Jefferson Clinton. Let's calculate what the key difference between these guys are via trigonometry. Look, I had to find some way of explaining this, okay? Here's the SO model. We are given the hypotenuse in this case, 110, and the angle of reference, 20. So the equation to solve this is as follows. Y over 110 equals sine 20. Through some basic algebraic stuff, eventually we multiply both by 110 because y over 110 is the same as y divided by 110. Boom, there you go, you got your answer. Y equals 37.62, which adds up because Caesar won about 38 battles, as opposed to Clinton, who couldn't even win over the people. Nice.
I did not have sexual relations with that woman.
So, I know what you're about to ask. So this only applies to all of these problems, but if the variable is on top, then you're just going to multiply as I just showed. But the alternative, being if the variable is below, is division. Now let's go over ka, which is cosine, adjacent over hypotenuse. Nick, stop playing Clash of Clans and listen up. So, in order to do this one, we here have people who have toilet paper facing the walls in the outer trash heap where they belong, and intelligent people. To find the difference, we're about to take the same approach as sine, but this time we shall replace the opposite with the adjacent, and boom, we got our answer. I know you're bored, but we're almost done. We just have Toa left. So Toa is the unicorn here, because now we're just trying to find the hypotenuse as opposed to one of the other two. So, as the name implies, we are going with opposite over adjacent, which is tan. And given that this is the Mediterranean in which this was, invented, it makes sense why the Greeks enjoyed tan. So those are the trigonometric ratios, and specifically how to understand, solve, and measure SohCahToa. But there's one final thing we should probably mention. How to actually find tan, cos, and sine is the simplest thing ever, and essentially adds up to simple division. Tan, opposite over adjacent. Cosine is adjacent over hype, because no one says hype anymore. And finally, sine is opposite over hypotenuse. So, we've reached the end of the journey. My little uninterested class is now a slightly older uninterested class. So now you're probably wondering, if the ancient Greeks, were able to come up with such advanced forms of thought and math, what happened? Well, they thought they would eventually rule the world, being big brains and all, because knowing trigonometry and geometry in general is important to construction, physics, infrastructure, and war. Napoleon even used it to do his things thousands of years later. So yeah, the Greeks came close to being mathematical and philosophical overlords, until the Latinos showed up.